we had a function -2 raised to x plus 1 plus 4. I want to find the x-intercept, and I want to find the y-intercept algebraically. We already graphed it using transformations. But now I want to find the x and y-intercepts algebraically. How do I find? Let's start with the y-intercept. How do I find the y-intercept? Awesome. So I have to find f of 0. Let's do this together. How much is 0 plus 1? How much is 2 raised to the first power? 2 multiplied by -1, -2. -2 plus 4 is 2. So the y-intercept is 0, 2. I go back to my graph and see if I need to make any adjustments. I was close. 0, 2. Very good. Now the x-intercept. Very good. So I have f of x equals 0. -2 raised to x plus 1 plus 4 equals 0. We have never seen this before. We've seen absolute value equations, linear, quadratic, polynomial, quadratic in form, absolute value, radical, rational, and so on and so forth. We have never seen this before. What type of equation is this? Thank you. Of course, it's an exponential equation. It is an exponential equation. We do not have experience with this, but common sense tells us to do what first. We have no clue how to proceed, but we have common sense and we can say, okay, do this first. Of course. Thank you. Perfect. Of course. Then you will say, I know nothing about it, but common sense tells me to do what? Very good. Not there yet, but you're right. I cannot. -1, multiply or divide by -1. 2 raised to x plus 1 equals 4. Okay, now, what is the base on the left-hand side? What would you like to have the base to be on the other side? 2. Let's see if we can. So the left-hand side is 2 raised to x plus 1. Can I write this as 2 raised to a power? It is. It's a lucky situation. Unlikely to happen all the time. When I can present the left-hand side and the right-hand side with the same base. At this point, I'm not simplifying, I'm not canceling, I'm not removing anything. I'm only thinking. 2 numbers are equal. And they have the same base. What has to happen with their exponents? They must be equal. So from here, this will happen only if x plus 1 equals 2. If x plus 1 is never 2, the left-hand side will never equal the right-hand side, and the equation has no solutions. But it happens that x equals 1. So the x-intercept is 1, 0, and we solved our first exponential equation. And my graph is not perfect, of course. I'm going to say, okay, this is 1, 0, and this is 0, 2. So this was our first exponential equation. Okay, so we continue with 4.2, and we are going to look on page 490. Let's talk about domain of log functions. Domain of log functions. And let's start with, let's say, 77 on page 490. We are given f of x equals log of 2 minus x. If I see log and there is no base, what do I conclude? Base 10 indeed, common log function. Correct. So here the problem is only asking us to find the domain of this function, nothing else. And remember, we don't do anything to the function itself when we're trying to find the domain. We have to write something that will give us, solve it, and that will give us a domain. But we are not doing anything to the function. So what do I have to write and solve in order to get the domain of this function? Okay, we don't know. So let's go back to our graphs. So this is a log with a base less than 1. I shouldn't look at that graph, though. I should look at this graph because in our case we have base 10, common log, which looks like this. What is the domain of this function? So log cannot be applied to quantities that are not strictly greater than 0. Now, I'm going back to my function. What is log applied to here? Let's read it. Good. What type of number 2 minus x must be for the log to exist? Good. That's all I want you to say. 2 minus x must be greater than 0 for this function to exist. Negative x greater than negative 2. I divide or multiply both sides by negative 1. I get x and 2. Very good. I have to change the symbol. So I'll change from greater than to less than. And then the domain of this function is negative infinity 2. Very similar with the concept for the square root. The quantity under the square root could be 0, though, not here. Log cannot be applied to 0. Okay, let's look at another problem, like let's say 76. And also graph it using transformations. This time, 76 on 490. We have f of x equals log, and it's base 5 of x plus 6. We want two things here. We want, number 1, to determine the domain of this function, and number 2, we want to graph it using transformations. What do I have to write in order to determine the domain of this function? Awesome. That's all I needed. Thank you, Danielle. So then the domain of this function is negative 6 to infinity. Now, I want to identify the base function. And then the only transformation that is applied to the base function. So what is the base function? Which function did I use to create this function? Five is not a function. Say it again. Log base 5 of, if there is no variable, there is no function. Log base 5 of log base 5 of x. That's the base function we used. Good. So then log base 5 of x plus 6, what does this do? What transformation is this when I change x into x plus 6? Left 6. Does it make sense? Look at the domain. Does it make sense? Left 6. Good. So I'm going to graph the base function. The base function, is it increasing or decreasing on all its domain? Very good. The base is greater than 1. Where does it cross? Where does the log function cross the x-axis? 1, 0. Good. Now, does this function have an asymptote? Yes. So when yes, at x equals 0. When I shift the graph with a vertical asymptote to your left 6, what do I have to shift first?
The asymptote.
Excellent. So I have to shift the vertical asymptote 1, 2, 3, 4, 5, 6 And now please give me my indicator, my point that I'm working with. Where does it go?
-5.
Awesome. So this is log base 5 of x plus 6. Any questions? I like to look at a word problem. You tell me what you're interested in. We have a function, which is a natural log function, that models the wife's weekly housework hours. Another function, also logarithmic function, that models the husband's weekly housework hours. We have students in psychology, in a psychology class that took a final examination, and that is determined as modeled using a log function. Which one are you interested in? No housework, I think. Yes or no? Psychology class?
Sure.
Okay. This is a good example for you. Good. So let's look at the psychology situation. Students in the psychology class took a final examination. This is problem 119 on page 491. Students in the psychology class took a final examination as part of an experiment to see how much of the course content they remembered over time. They took equivalent forms of the exam in monthly intervals thereafter. Yes? Questions?
Oh, no.
The average score for the group, F of T, average score for a group, for the group. T is in months. The function was modeled by a function, 88 minus 15 natural log of t plus 1. We're asked 3 questions, A, B, and C. What was the average score on the original exam? F of t on the original exam. I'm copying the problem so I can get rid of the book. 2 months, and then 4, and then 6, and then 8, then 10, and then 12 months. And then sketch the graph. Okay, it says sketch the graph either by hand or with the graphing utility. I was going to say TI 84. Okay, ready? So we're given a function. Can anyone say anything about this function? What type of function is it?
No.
Right. It has natural log. It has ln. It's a natural log function. We've never seen this before till today. Okay, so this gives the average score for the group, and t is number of months. So we're asked to find f of t, the average score for the group, on the original exam for the entire class. The average exam at the original score. What am I really asked to do in part A? I'm asked to, when we talk about original exam score, exactly. 0 months at the end of the course. Very good, f of 0. Good, we're going to determine that in a minute. Then in part B, what are we trying to determine? Very good. And then f of 4, and then f of 6, and then f of 8, and f of 10, and f of 12. Let's put the function in. In y equals, please. Clear if you have anything else. 88 minus 15 natural log. It pops with parentheses, of course. We don't have t, but we have x plus 1 and close the parenthesis. So now, after we put in the function, 88 minus 15 natural log of x plus 1, let's go to second and table. And I plug in what I need. 0, 2, 4, 6, 8, 10, 12. Wendy?
What?
You okay?
Yeah, I totally screwed up.
That's okay. So I'm copying. Score 88, 71.5, 63.9, 58.8, 55.0, 52.0, 49.5. Questions? What do you notice? Yes, please.
For some odd reason, my graph calculator is off at 1. But my 0 is an error, my 2 is 88, 4 is the second one.
Not allowed. Because you put -1 instead of +1.
What?
You put -1 instead of +1. The function has impossible. You cannot plug in. You plugged in 0 and log. That's why you got error. Look at the function one more time. And you have too many parentheses. So it's 88 minus 15. There is no need of parentheses. Natural log x plus 1. Is that okay?
Yep.
We got it?
Yep.
Perfect. So, here it is. What do you notice? As a group, today, we get a score of 88. A month later, our score is 71.5. And then 63.9, blah, 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 till almost 50%. A year later. Yes. It's going down. Good. So now we can graph this function. So let's graph it. Let's go to the viewing window. So, at the viewing window, we want x to be where? What? What is x? Between 0 and? X. What is x in our problem? 0 to 12. From 0 months to 12 months. So 0 to 12 with a scale of 2. Now, what do we want y? How low was y? 50.
49.
Right, roughly 48, 49. Right. What was the maximum?
88.
Good. We don't want to go beyond 88. Good. So then y minimum, let's say -2 because we want to see the, or -4 because we want to see the x-axis. And I'm going to say 100 with a scale of 20. And now I hit enter. And that's all I care about. Between x equals 0 and x equals 12, 12 months. It's coming down from 88 average score in a year to roughly 50%. And that's the graph. Any questions? Any questions on this? Okay, so I know I have 4 minutes plus 6, correct? Left. Okay. So in 4 minutes, I'm just going to show you something new, and then in the last 6, something that is not new. So 4.3, properties of log. There are 3 properties for log functions that no other function has. No other function has these 3 properties. Very special. Here is the first property. Log in any base apply to a product. So this is the product rule. Product rule. What does it say? Log applied to a product can be changed into the sum of logs. Log in the same base of the first quantity, the first factor, plus log in the same base of the second factor. This property has to be remembered dynamically if you want. I can start here and change it into a sum of 2 logs, or I can start with a sum of 2 logs in the same base and change it into this. So here's an example. Log base 5 of 2x can be written as log base 5 of 2 plus log base 5 of x. And going backwards as well, meaning, let's say log base 3 of 2 plus log base 3 of 7. This can be condensed into log base 3 of, that's it. So this is the product rule. The next one will be the quotient rule, and I would like you to come up with the answer. Common sense. Log base A over ratio. What do you think this will be?
Log base A minus.
Very good. Awesome. So let me show an example with going backwards. Let's say log base 3 of 10 minus log base 3 of 5. If you condense it into log base 3 of 10 over 5 of 2. So this is the quotient rule. And the last one is the power rule. Log base A of x to the nth power. The power goes in front as a factor. It multiplies. It multiplies the log. This is the power rule. And here's an example. Log base 3 of x to the 4th power. How will I write it? Applying the power rule, how will I write this?
4 log base 3 of x.
What if I have this? -2 log of 5. How do I change it back? I don't want the number in front. So this will be log 5 raised to -2, which can be rewritten as 1 over 25 inside the log. I would like to practice these 3 properties. Expanding log expressions. Expanding log expressions. So let's start with 27 on page 501. And that is log base b of x squared y divided by z squared. Log base b of x squared y divided by z squared. Expanding means I am given log applied to a complicated, sort of complicated expression, and I want to use all possible properties, I don't have more than 3, to expand this fully. I will be starting with the quotient first. That's the starting point, in which I say log of a over b is log base b of x squared y and minus log base b of z squared. Because we know that when we apply log to a ratio, that is a difference of 2 logs. Agreed? We apply this property up here. Log of something over something else is log of the top minus log of the bottom. So log of the top minus log of the denominator. Good. Now I'm looking at the first one, and I realize that this is a product. You can put parentheses if you want to or not. If it's a product, it works without or with. It's up to you. So next step is I have to apply the product rule and rewrite the first quantity as log base b of, very good, and then plus
Log base b y.
base b of y minus log base b of z squared. Very good. So we're done with products, we're done with ratios, normally in the order of ratios and then products. But now I have one more property to apply. What is that property that I need to apply now?
The power.
The power. So this power becomes a factor in front. Remember, it's not plus. By factor, we mean multiplication. So this is twice, or 2 times log base b of x plus log base b of y minus 2 log base b of z. And this is fully expended. We cannot no longer expend or apply any property. Any questions on this? I wanted to make a following remark or note. This quantity is coming from the denominator. This is the only one that ends up with a negative in front of it. These two quantities come from the top. They both have positive in front. Okay, and let's look at one more, and then we'll stop. Let's say 36. We have log base 2 of the 5th root xy to the 4th underneath over 16, still underneath the 4th root. Well, this is a slightly more difficult situation, only because of this 5th root. But I do remember that the 5th root is the same with the power of what? 1 over 5. Thank you. So this is log base 2. Everything is raised to 1/5. And inside I have xy to the 4th over 16. Perfect. This time I have to start with that power. I cannot move into the ratio or the product. I have to start with that power. So when I start with the power, all I have to do is put the power in front. That's my first step. So I have 1/5 log base 2 of xy to the 4th over 16. 1/5 now stays outside waiting. And now I'm back to the previous example in which I had log of a ratio. How do I start? With log base 2 of, very good, but minus, because 16 is coming from the denominator, log base 2 of 16. Next step is 1/5. Now I have to break this up because it's a product. I will have log base 2 of x plus log base 2 of y to the 4th minus log base 2 of 16. Two more steps. The first one is clear. I have to move forward in front as a factor. And that's the power rule that I apply. So it's 1/5 log base 2 of x plus 4 log base 2 of y. And I have to think about this for a moment. Log base 2 of 16 is unknown. Log base 2 of 16 is unknown, but I know that this can be changed into 2 raised to whatever equals 16. 2 raised to whatever equals 16. What can exactly? So all this is replaced by -4. We were able to simplify it. Final step, I must distribute 1/5. So I have 1/5 log base 2 of x plus 4/5 log base 2 of y minus 4/5.